Tech in 5.
Ever wondered how top tech companies evaluate coding skills in interviews? Mastering coding challenges is your key to securing that dream tech job. Welcome to a new challenge in our coding interview series, solving the tic-tac-toe puzzle. If you've ever wondered how to outsmart your opponent in this timeless game, using your coding skills, you're in the right place. Let's unravel the secrets of making the smartest move in tic-tac-toe. Picture this, you're in the middle of an intense tic-tac-toe game, the board is almost filled, and it's your turn. How do you decide where to place your mark? Your challenge is to write a function that determines the best next move in a tic-tac-toe game. You'll be given the current state of the board, and your playing symbol, X or O. The function should analyze the board and return the coordinates of the most strategic move. Whether it's securing your win, blocking your opponent, or setting up for future victory, your algorithm needs to find the optimal choice. Think strategically, and let's find that winning move. In our first part to the challenge, we're focusing on the immediate win check. Our function findImmediateWin scans the board for a spot where the player can win the game immediately. We iterate through each cell. If a cell is empty, we temporarily place the player's symbol there, and then see if this move wins the game. If it does, we return the coordinates of this winning move. If the temporary move doesn't result in a win, we reset the cell to its original state and continue the search. We now turn our attention to the defensive tactic, the block opponent's win. We imagine it's our opponent's turn, and call the findImmediateWin function with their symbol. If the function returns a move, that's where our opponent is about to win on. So, we make our move in that exact spot, effectively blocking their path to victory. Now, let's dive into one fascinating algorithm, the Minimax Algorithm. Used in two-player games, like tic-tac-toe, this algorithm predicts the future of the game to make the best possible move. Picture the Minimax algorithm as a tree of possibilities. It starts from the current game state and branches out to all possible future moves. And it goes further, considering the opponent's responses, then your next moves, and so on. In this tree of possibilities, when it's the AI's turn, the algorithm looks for the move with the highest score, maximizing its chances of winning. When it's the opponent's turn, the algorithm seeks the lowest score, minimizing the chances of victory. Let's dive into the code of the Minimax algorithm. The goal of our function findBestMove is to evaluate the best possible move for the current player. It iterates over each empty cell of the board. Then, it simulates placing the player's symbol there and calls Minimax to evaluate the move. For each potential move, we evaluate the score. The move with the highest score is remembered as the best move. Now, let's unravel the magic of Minimax. The function first checks for terminal conditions, a win, a loss, or a draw, returning scores of 1, -1, or 0, respectively. These scores are the heart of our decision-making. In the is_maximizing phase, the function tries to maximize its score. It iterates through possible moves, calling Minimax recursively to play out those moves, selecting the one with the highest score. In the minimizing phase, the roles reverse. Here, the algorithm assumes the opponent's turn and predicts their best move, aiming to minimize the score, representing the worst-case scenario. By alternating between maximizing and minimizing at each level of recursion, the algorithm builds a tree of potential game states and outcomes, eventually choosing the path that leads to the best possible outcome, assuming optimal play from the opponent. And that's how our Minimax algorithm makes the Tic-Tac-Toe AI unbeatable. It's not just thinking about the next move, but also all possible responses and counter-responses, ensuring it's always one step ahead. Now, let's take a moment to reflect on the strategies and algorithms we've explored. We started with the fundamental tactics, identifying immediate winning moves. This strategy allows our AI to seize victory whenever it's just one move away. Then, we shifted our focus to defense with the opponent block strategy. By predicting our opponent's potential winning moves, we ensured our AI stays in the game. The core of our strategy has been the Minimax algorithm. This advanced method simulates future moves, considering all possible outcomes, to select the most advantageous move. It's like a chess grandmaster, thinking several moves ahead. Of course, there's always room for optimization. Techniques like alpha-beta pruning can enhance the Minimax algorithm, making it more efficient by eliminating the need to explore less promising paths. Whether you're preparing coding interview or just a programming enthusiast, we hope this journey has been as enlightening for you. Got a different solution? Feel free to share your ideas in the comments.
Stay tuned for more videos on Tech in 5.